Hi everyone, welcome back. We are continuing in Module 2. We are still in Topic 1. We're on Lesson 4, Activity 1, which is on page 213. Introduction to Ratio Tables. Your weight on Earth is the measure of the amount of gravitational attraction exerted on you by the Earth. The Moon has a weaker gravitational force than Earth. The ratio of weight on Earth to, remember the colon is the word to, weight on the Moon is approximately 60 pounds to 10 pounds. So for every 60 pounds someone weighs on Earth, you can expect to weigh 10 pounds on the Moon. You can use ratio tables to show how two quantities are related. Ratio tables are another way to organize the information. So let's think about, how do the numbers in the table relate to each other? Worked example. The table represents three equivalent ratios of weight on the Earth in pounds to weight on the Moon in pounds. Start with a ratio of 60 pounds on Earth to 10 pounds on the Moon. And then if we look here in the reddish, it's kind of hard to see on here. That is a division. So it says 60 divided by 2 takes you to the 30. And then down here, 10 divided by 2 gives you 5. So the 60 and 10, 60 pounds on Earth to 10 pounds on the Moon is equivalent to 30 pounds on Earth and 5 pounds on the Moon. And that makes sense. 30 is half of 60, 5 is half of 10. And I find it very interesting right here in the blue, they are saying to add, and then they're showing us that when you add, you get this column. So it's saying when you add 60 plus 30, you get the 90. When you add 10 plus 5, you get the 15. Now this is different than what we had yesterday in our lesson, where Sal was using additive reasoning to increase on the double number line. So this one, we're working with two ratios that are the same. They are equivalent ratios to gain this one. So then it says, number 1, verify that the three ratios shown are equivalent. So this is a really handy way, I guess is a good word, for you to know if the ratios that you're setting up are in fact equivalent to one another. So we have our first ratio is 60 pounds on the Earth to 10 pounds on the Moon. Remember that this in fractional form, it acts like a fraction, so we can divide that. 60 divided by 10 gives us 6. We can write that as 6 over 1. So let me just show you, just like we've been doing. 10 divided by 10 gives us 1. 60 divided by 10 gives us 6. 60 divided by 10. 60 divided by 10. Do you see that that all works out the same? So our quotient for 60 to 10 is 6. Next one, we have 30 over 5. So if you just divide that, 30 divided by 5 is in fact 6. And we can put it over 1. 5 divided by 5 is 1. 30 divided by 5 is 6. Again, we have a quotient of 6 over 1. Last, we have 90 over 15. 90 divided by 15 is 6. 15 divided by 15 gives us 1. 90 divided by 15 gives us 6. Again, we have a quotient of 6. So using the quotient is another way to check to see if ratios are in fact equivalent. So we can say the quotient of each ratio is 6, so they are all equivalent. Okay, then it says, can you show a different strategy to determine the ratio of 90 pounds on Earth to 15 pounds on the Moon? So they mean different than adding the 60 and 30 and the 10 and 5. So we could start with the 60 over 10, and let's see, is it equivalent to the 90 to 15? So how do you go from 10 to 15? We know we're scaling up. We would multiply by 1.5. So is 60 times 1.5 equal to 90? So let's try it. So 60 times 1.5. 5 times 0 is 0. 5 times 6 is 30. Okay, I'm finished with the 5. I'm going to put a 0 here, move over. 1 times 0 is 0. 1 times 6 is 6. Now I'm going to add. I have a number in the tens place, no place here, so my decimal needs to show tens place or one number after the decimal, no numbers after the decimal, so we need a total of 1, so 90.0. So we just verified by doing times 1.5. Excellent. Okay, I'm going to pause so I can flip the page. Be right back. Okay, so we have flipped the page. We are now on page 214. It says, consider the strategies used by Howard, Carla, Mitsu, and Ralph to determine the weight of a 120-pound person on the moon. So they just added the 120 from this table right here. Now, for some reason, kids seem to, this is just a little side note, kids seem to go along pretty well understanding that I can show this. And you guys do really well with, how do I go from 10 to 5? And doing, well, I divide by 2, and 60 to 30, and divide by 2. But for some reason, when we put it in a table, kids get very confused. I want to show you how this right here setup gets turned into the table, because then we had the 90 over the 15. If I were to just do this, I'm going to use a different color so it kind of stands out and you can see what I started with. If I just box it in and then separate each of those ratios like this, I just turned my initial fractional forms into a table. It's really nothing more than that. Again, kids seem to do really well when it's just the fractional forms. And then for some reason, when you put a box around it, kids get confused. So then they added the 120. And is that true? So 60 times 2 gets us the 120. So 10 times 2 gets us 20 here. Okay, so that does work. Carla said, I also got a ratio of 120 pounds on Earth to 20 pounds on the moon. And she used a double number line. So where this didn't put them necessarily in ascending order, this one did. It doesn't change things. It's still 30 to 5, 60 to 10. Okay, so if this interval is going up by 30s, 30, 60, 90, 120 would be next. This interval is increasing by 5s, 5, 10, 15, 20. So 120 to 10, or to 20, I'm sorry. Mitsu said, well, I know, so had this right here, and then is looking at the 120, said, I know if I add 30 plus 90, 30 plus 90 equals the 120. So 5 plus 15, if I add that, that equals 20. So yet another way to do that. Moving on to page 215, let's look at what Ralph said. Ralph said, the difference between 90 and 120 is 30. Okay, so added 30. So I just added 30 to the 15 and got 45. Does that work? No, that's what Sal did. He used an additive reasoning, but if we were to verify the 120 and 45 to see if they, remember all of these when we divided had a quotient of 6. does this one, 120 divided by 45. Well, let's see. How many times does 45 go into 120? Does it go in? It would have to go in 6 times evenly, does it? So 45 times 6. 6 times 5 is 30. Put a 0, carry a 3. 6 times 4 is 24, plus 3 is 270. We have 120. So does that work? No, it doesn't. So that would have to be 270 here for that 45 to be correct. That would be, if someone's 45 pounds on Earth, they're on the moon, they're 270 pounds on Earth. So what is, let's try maybe 45 times 2 gives us 90. And when we subtract there, we get 30. We put a decimal, add a 0, bring it down. How many 45s can we get out of 300? Decimal goes here. 6. 270, subtract, get 30. We would have to add another 0, bring it down. The point is, we do not get a quotient of 6. So that is not correct. His reasoning is not correct at all. Okay, so question 1 then says, compare Howard and Carla's strategy. So now that we've looked at them, what did Howard and Carla do? So Howard scaled up by 2, and Carla made a double number line. So Howard scaled up by 2. Carla made a double number line. By matching the intervals. For every 30-pound increase on Earth, there was a 5-pound increase on the moon. Explain Michu's reasoning, then verify the ratio 120 pounds on Earth to 20 pounds on the moon is a correct equivalent ratio. So she did what? So she added the equivalent ratios $35 and 90 over 15. Okay. Give you a chance to write that. It says, then verify the ratio 120 pounds on Earth to 20 pounds on the moon is a correct equivalent ratio. So if we do 120 divided by 20, we get 6 over 1. So just like we went back on the other page and verified that they were all equal to 6 over 1, it works here as well. Okay, so Ralph's isn't correct because he used additive reasoning. instead of multiplicative. Okay. And what do we have on this other page? I'm going to peek. Okay. So if you need to pause to finish writing that, please do. I'm going to flip it over to keep the video short. Michu said, I see another equivalent ratio from Carla's work. So 30 pounds on Earth equivalent to 5 pounds on the moon, 120 pounds on Earth to 20 pounds on the moon, 150 pounds on Earth to 25 on the moon. Is Michu correct? So is she correct? Would 150 be the equivalent of 25? So yes, she added, what did she add? So 30 plus 120 gives you the 150. 5 plus 20 gives you 25. So she added the corresponding parts of each equivalent ratio. Next it says, show a different strategy to verify the equivalent ratio of 150 pounds on Earth to 25 on the moon. So let's see. Could we add together, could we add this 60 plus 90? 60 plus 90 equals 150. And its corresponding parts are the 10 and 15, and those together equal the 25. We could also, one other way we could show this is we could take this 30 to go to 150, we could do using multiplicative reasoning times 5. So then 5 times 5 would give us the 25. Okay, that is the end of activity 1, and we will see you on the next video.